This is a complimentary video to go along with today's notes in regards to solving two-step equations. Let's take a look at example number 1, where we have equation 6x minus 12 is equal to 24. Now, as we said today in class, the first thing we should focus on is our constants. When we look for our constants, it is important to make sure that we include the sign on the number. Therefore, our entire constant here is negative 12. At this point, we have to find a way to get rid of the negative 12, and therefore we will use its additive inverse, which would be a positive 12. We're dealing with an equation, which therefore means that we need to keep both sides balanced. To do this, we're going to use the addition property of equality, which means if we add 12 to one side, we're going to add 12 to the other side. When we add 24 and 12, we get 36. This 6x will just carry down. And now if we look at the negative 12 and the positive 12, they're additive inverses and thus add to 0. By extension of our additive identity property, 6x plus that remaining 0 will give us 6x. Therefore, we don't need to write the plus 0 in our equation. At this point, we now have a one-step equation. We are trying to get rid of this coefficient. In order to do so, we're going to apply our division property of equality. We divide both sides by 6. 36 divided by 6 will give us an answer of 6. When we divide 6x by 6, we know that 6 divided by 6 will give us 1. By extension of our identity property for multiplication, 1 times x will give us x. At this point, we can see that our variable is isolated, meaning it's by itself, also meaning that the variable is on one side of the equation and all of the numbers are on the other side. This means that we have our solution, and x is equal to 6. Let's take a look at the second example here. We have 2z plus 9 is equal to negative 11. This one's a little bit different because our constant happens to be a positive. Now, if you remember in the first example, when we had this negative, we applied our addition property of equality. Now, since we have a positive constant, we're going to use our inverse or subtraction property of equality. Once again, we add up the side that has the solution. Negative 11 combined with the negative 9 reinforces our integer rules. Same sign, add them together, and thus we get negative 20. On the other side, 2z is carrying down, and 9 minus 9 will give us a sum of 0. Once again, applying our identity property of addition, 2z plus 0 will give us 2z, and thus we do not have to worry about writing our plus 0, and we can cancel this out. Now we can apply our division property of equality, which means we are getting rid of our coefficient of 2. Divide both sides by 2 here. We can apply our identity property of multiplication again, leaving us with z is equal to negative 10. At this point, we have applied our identity property of addition, our identity property of multiplication. We've also used our addition property of equality, our subtraction property of equality, and our division property of equality. We have one more property that we discussed in class today, and that was our multiplication property of equality. Now, one of the key signs that you'll have a situation like that is when you have a fractional coefficient. such as 1/4 or 2/3. But obviously we're getting ahead of ourselves. We need to focus on the constant first. In this case, that happens to be -9. Apply your addition property of equality, leaving us with 1/4 g is equal to 2. And now we can apply our property, our multiplication property of equality. How do we get rid of a 1/4? Well, this is actually using our multiplicative inverse. The inverse of 1/4 is the reciprocal, or 4. If we do it to one side, we do it to the other because of our multiplicative property of equality. Thus, the 1/4 and the 4 will cancel each other out, leaving us with g. The reason why the 4 and the 1/4 cancel each other out is because of our multiplicative inverse property, telling us that a number multiplied by its reciprocal will give us a product of 1. We finish this off by multiplying the 2 and the 4, giving us 8, and we have our final solution. Example number 4 is very similar to number 3, but looks more confusing. We follow the same procedure. Get rid of the constant. In this case, we'll use our subtraction property of equality. That will leave us with 2/3 k is equal to -18. And now, we once again use our multiplication property of equality. We are going to use the inverse of this 2/3. The inverse of 2/3 is its reciprocal, or 3/2. We are multiplying here, and if we do it to one side, once again, due to equality, we multiply the other side by 3/2. Applying our multiplicative inverse property once again, 3/2 multiplied by 2/3 will give us a product of 1, and then applying our multiplicative identity property, we have 1 times k, or just k. The other side is a little bit more of a problem. We are multiplying an integer by a fraction. This is actually a good time to review some of our skills. In order to make the -18 into a fraction, we have to think of what number we can divide -18 by in order to keep it -18. And if you know your division facts, the only number you can divide it by is 1. Now we can multiply. We go straight across. -18 times 3, and if you need to, let's practice our multiplication skills right here on the side. 3 times 8 will give us our 24, and 3 times 1 will give us 3, plus the 2 we carried over, or 5. A negative multiplied by a positive will leave us with a negative answer. So the numerator is 54, and our denominator, 1 multiplied by 2, will give us a product of 2. Now, of course, this answer is not fully simplified, so let us finish this off. A fraction represents division. -54 divided by 2 will leave us with the final answer of -27. But that is our solution.